Is it really the audio quality that bad in the back of the room?
It's pretty bad.
Yeah.
You know, Eunice is minding through her desk. Eunice is standing right now. She doesn't mind. She doesn't mind. She might steal your cell
Just
phone.
gotta give me a fee of $5.
Whose is this? I'm moving your phone. Where this is. There you go. Now, there you go. Collection.
Yay.
You look so cool.
I like this one.
That's a nice cover.
Yeah.
Okay. So in your introduction, first you're going to state restate the purpose, which is the purpose of this lab is to find the relationship between force, mass, velocity, and radius for something moving in a circle. To do this, we are going to focus on the velocity as our dependent variable. We're going to use a tube with a string threaded through it, and we're going to hang some weights below the tube, and then we're going to have a swinging mass on the end of the string above the tube. We're going to swing that tube around a circle, and the mass above the tube will go in a circle, and we're going to measure the radius for that each individual circular path and put pieces of tape beneath the tube to make sure that the radius doesn't change. So we're keeping track of the radius, the force, and the mass, and seeing how changes in those three affect the velocity. We're therefore going to do three separate labs. We're going to do one lab where we're changing the force caused by the weights hanging below the pipe, and we're going to see how increasing that force changes the velocity. We expect the velocity to have to go up, because if you're pulling on it harder, you have to swing it faster to hold up all that extra weight. The next lab we're going to do is we're going to change the mass on the end of the string. So we're going to keep the force below constant and the radius constant. We're going to keep changing what we're swinging, using 1 washer, then 2, then 3, all the way up to 6 washers on the outside of the string. And as we're swinging it around, we're going to see how that affects the velocity. And we expect it to have to slow down as you add more mass, because just like a hobbit in Lord of the Rings picks up a tiny mace and swings it around his head, it's not going to be that much of a problem for him. But if he picks up a gigantic flail and starts swinging it around his head, it will make him fly off in a straight line instead of a circle, because a heavy mass requires a slower speed. So we expect the heavier masses to drive the velocity down. The final relationship is going to be changing the radius and seeing its effect on the velocity. Now the way that's going to work is we're going to keep the forces on the bottom of the string constant, we're going to keep the masses that we're swinging around a circle constant, or we're going to keep stretching out the string, removing the tape and placing it in a different spot so that the radius gets larger and larger. And this was very difficult for us to figure out whether or not it's going to be going faster or not. So we went to the small gym. And yes, everyone, you are going to write down all about our experiences in the small gym in your report. We're going to go to the small gym. And we're going to take off our socks, and we're going to run in a large circle. And we're going to time ourselves. And then we're going to run in a circle that's exactly half that size and try to get around in exactly half the time. And when we did that, we found that no one in the entire class could run around the smaller circle at the same speed as the larger circle. They had to slow down or they would slip and fall. And so this shows that as radiuses get smaller, the velocities must also get smaller, or you won't be able to maintain circular motion. So circular motion requires that the velocity goes down as the radius goes down. So conversely, as the radius goes up, the velocity should go up. And so now we know what to expect. When we're increasing the radius, we should also see an increase in the velocity. But what we don't know is the exact way the velocity is going to increase. So we're going to do each lab, and we're going to get graphs. And when the graphs are formed, if they are curves, we are going to linearize them by looking at the formula and figuring out which way to linearize it based on the formula. Once we linearize it, we're going to find the slopes of those lines of the linearized graphs. And using those slopes, we're going to figure out the meaning of the slope. Using both the combination of all three labs' mini formulas and the suggested meaning of the slopes based on their units, we should be able to figure out what each formula's full relationship is. We expect that the slopes of each of the three labs will be related to the numbers that were kept constant during that experiment. Specifically, in the force versus velocity lab, the slope should have something to do with the radius and the mass that were held constant. In the mass versus velocity lab, the slope should have something to do with the radius and the force that were held constant. And in the radius versus velocity lab, the slope should have something to do with the force and the mass that were held constant. When we discover the relationship between the constant variables in the slope, and we discover the relationship between the two variables that are being tested, each formula should break down to a single common formula that connects all four of the variables: force, mass, radius, and velocity. Stop recording. Okay, now, if you're sitting there going, holy crap, that took a long time. Yes, it did. Yes, it did. All right? So if you think you can stumble onto this lesson,